Good evening, class. We are looking at practice test number 4. Here's chapter 9, inferences from 2 samples. So it's very similar to one sample as far as the concept is concerned and continuing in the same manner. So let's start with the very first question. Do you mind if you read it for us, Abnian? All right. Among 843 smoking employees of hospitals with the smoking ban, 56 quit smoking 1 year after the ban. Among 703 smoking employees from a workplace without the smoking ban, 27 quit smoking a year after the ban. Part A, is there a significant difference between the two proportions? Use a 0.01 significance level. And for part B, construct the 99% confidence interval for the difference between the two proportions. All right. So let's look at what is given. We're dealing with a binomial distribution. There are two groups. In the first case, n sub 1 is 843. X sub 1 is 56. For the second group, n sub 2 is 703. X sub 2 is 27. And alpha is a 0.01. To do the test of hypothesis, we first have to calculate a couple of things. For example, P bar is X sub 1 plus X sub 2 divided by N1 plus N2. We are going to calculate that first and foremost. Then we're going to use this test statistic when we get to that step. So first and foremost, P1 hat is X sub 1 over N sub 1. 56 over 843. And with a bunch of decimals, 0.0664. P2 hat is X sub 2 over N sub 2. 27 over 703 with a bunch of decimals, 0.0384. P bar is X sub 1 plus X sub 2 over N sub 1 plus N sub 2. And obviously, Q bar is 1 minus P bar. So the first step is H0 and H1. H0, P1 minus P2 equals 0. We always give the equality to H sub 0. H sub 1 or H sub A, P sub 1 minus P sub 2 is not equal to 0 because the question is asking, is there a significant difference between the two proportions? It doesn't say less than, greater than. We are just looking for a difference, which makes it a two-tailed test. And since that question is asking, let's go with that to be the claim. The next one is to calculate the test statistic using this formula. And for that, we needed to calculate P1 hat, P2 hat, P bar. All of them have been calculated already. So let's plug in. So we are plugging in everything into this formula. Again, the formula may be a little bit complicated, but you have a formula sheet and you plug in everything. And that results in test statistic Z equals 2.4319. The next step is to find the critical value which comes from the choice of alpha, which is a 0.01. Z is plus minus 2.575. To make a decision, let's do the drawing. So the drawing will help us make a decision. So we have this Z graph or normal distribution graph. We have the critical values of negative and positive 2.575. We want to see where this number test statistic lands with respect to those two. So take a look at the graph. So negative 2.575, positive 2.575. And as you can see, this number is clearly in between. And it doesn't have to be to scale, but clearly in between, which makes it way into the non-rejection region. Therefore, your first step of decision making is to fail to reject the null hypothesis, or just don't reject. So fail to reject the null hypothesis. So if we are not rejecting the null hypothesis, that means we are rejecting H1 in essence. The claim becomes false. There is not a significant difference between the two proportions. Fail to reject the null hypothesis because this test statistic is in between. The claim is false. There's not a significant difference between the two. All right. Let's look at the technology. We use two proportion z-test. One second, please. So two proportion z-test, and we plug in the information x sub 1, n sub 1, x sub 2, n sub 2. Now p sub 1 not equal to p sub 2, you choose that one, you calculate, and it gives you the information. Notice what it gives you. It calculates p1 hat, it calculates p2 hat, of course with a lot more decimals. It calculates p bar, and this is the p-value equal to 0.149. This is larger than alpha of 0.01. We have the same decision, which is fail to reject the null hypothesis. We're going to continue with the same question. We're going to go to part B, construct the 99% confidence interval for the difference between the two proportions. This is the information from the previous page, n sub 1, x sub 1, n sub 2, x sub 2, alpha, p1 hat, p2 hat, p bar, all of the above. By the way, as far as the p-value is concerned, it would be the area to the right of the test statistic times 2. So the p-value, I want to go back to this page, I would show it as follows. This would be the p-value, and then times 2. Why times 2? Because it's a two-tailed test. All right, so as you can see, the formula is similar. We had p hat plus minus e. Now it's p1 hat minus p2 hat plus minus e. That's how you calculate the confidence interval, with the e being z alpha over 2 p1 hat q1 hat over n1 plus p2 hat q2 hat over n2. And that's different than using a p bar. So let's plug in. We have all the numbers we want. and even with more decimals, I might choose. So E is calculated to be 0.0289. P1 hat minus P2 hat is 0.028022. We are going to add and subtract that number. Remember, you really want to carry out a lot of decimals at the end. You can go with however many decimals they want. So we are going to add and subtract. And the result is a negative number, no matter how small it is, to a positive number, no matter how small it is. So if you were to make a decision based on confidence interval, you would say, because the confidence interval limits contain 0, there is not a significant difference between the two proportions. Fail to reject the null hypothesis. We will get to the same decision. As far as technology is concerned, we can use confidence interval for two proportions. We plug in the information they ask us, just as before. And when we calculate, we end up with this answer. First, I want to look at the right side. I hope you see that the right side, 0.05695, is the same as what we have here. Now, negative 9, e minus 4, that means negative 9 times 10 to the power of minus 4, which makes it minus 0.0009. So this, you should be able to represent it as a decimal. Minus 9 times 10 to the power of minus 4. Let me write that. That's the meaning of it. And means this number, as you can see, they're almost identical. If you were to round it right here, it becomes the same. All right. Would you read this question, please?
Company A claims that its yogurt cups contain, on average, fewer calories than that of a competitor. A sample of 50 yogurt cups of Company A produced an average of 141 calories per cup with a standard deviation of 5.4 calories. A sample of 40 yogurt cups of a rival company, B, produced an average of 144 calories per cup with a standard deviation of 6.3 calories. A, if the calories of the yogurt cups for Company A and Company B have different variances, use a 0.01 significance level to test the claim.
Perfect. Now we want to do the test of hypothesis. First, we're going to write the information here. Company A, N sub 1, 50, X sub 1 bar, 141 calories, S sub 1 is 5.4. We're just translating this, making it easy to understand. Company B, N sub 2 is 40, X sub 2 bar is 144 calories, and S sub 2 is 6.3 calories. Now, we want to do the test of hypothesis at alpha of a 0.01. The other thing that is important, different variances. This comes to play a big part later on. You'll see it in a moment. For now, let's write the first step. H0 mu1 equals mu2. One might write mu1 minus mu2 equals 0. It's the same thing. H1, mu1 is less than mu2. Okay, because we are claiming company A is claiming that it has less calories, mu1 less than mu2. Now, again, I want to write this. If you have mu1 minus mu2 equals 0, then you want to write mu1 minus mu2 less than 0. This is the reason it's less. This is the claim. It's a left tail test. Let's calculate the test statistic according to the formula. T equals x1 bar minus x2 bar over the square root of s1 squared over n1 plus s2 squared over n2. We have everything here. Just plug in. Do the math. Your test statistic is negative 2.3901. Now, the next step is to find the CV critical value where alpha is a 0.01. And so what is the degrees of freedom? And the degrees of freedom, if you want to go with the table and limitation with the table without the technology, you have to use smaller of the two, which means this one is 50 minus 1, 49. This one is 40 minus 1, 39. And between the two, you choose 39 and look up the table. And if you have number 39 in the table, fine. If not, the closest number. So when you look it up, you end up with negative 2.426. Now, to make a decision, I highly recommend you do the drawing. So let's do the drawing and see what happens. When we do the drawing, when alpha is 0.01, CV is negative 2.426, and test statistic is right somewhere here. Again, it doesn't have to be to scale, but clearly it's in the non-rejection region. Any tail would make it a rejection region, non-rejection region. Therefore, fail to reject H0 or do not reject H0. If you're not rejecting H0, what are you rejecting? H1, which means you're rejecting the claim. The claim becomes false, and there's not enough evidence to support the claim that the company A's yogurt cup contain on average less calories than that of its competitor. That's how you would write that. Again, pay attention to the fact that it says use different variances, and this is without the technology. And I will discuss the technology in a moment also. We're going to look at the same question, and we write alpha degrees of freedom, the T that we found, which was the test statistic in this one was the critical value, negative 2.426, and the test statistic was negative 2.39, as you can see from the graph. So it's a left tail test. Area to the left of test statistic makes it a p-value. So this area. And so clearly from the graph, you see that the p-value is larger than alpha of 0.01. But as far as the table is concerned, take a look at this table. Notice this is the number we are looking at. And why is that? Degrees of freedom is 39. So you go to the left column, look for 39. We are looking for negative 2.3901. It doesn't exist here, but clearly it's between these two numbers. You look at the positive portion of it, it doesn't matter. It's between these two numbers. And therefore, area in one tail is between these two numbers. So the p-value is somewhere between these two. And it's clearly larger than alpha of a 0.01, which means we get to the same decision, fail to reject the null hypothesis. Decision is in agreement with the previous one. What I want to go over is what happens if we use technology, everybody. Take a look. We're going to do two sample t-tests. We're going to go through the process and we're going to enter whatever they ask us, x1 bar, s, n sub 1, x2 bar, s2 bar, s2, n2, all of them. And we are not going to pull it because we are assuming, remember what we read in the previous page, different variances. If they said equal variances, then you go with pulled one. Again, I can't emphasize this enough. This is not pulled. Why not? Different variances. So with that being the case, take a look at what you get here. We have a different result with the calculator. Here's the reason. Degrees of freedom has a very complicated formula, a plus b quantity squared over a squared over n1 minus 1 plus b squared over n2 minus 1, where a is s1 squared over n1 and b is s2 squared over n2. You don't have to worry about that. But because of that, when the calculator calculates the degrees of freedom, it is no longer 39. This is what we picked, the smaller of the two. But in this case, take a look at what happens. Degrees of freedom using this formula is calculated at 77.11464,164. Different degrees of freedom result in a different critical value. And therefore, a different p-value. Now, if you look at this p-value, 0.0096, this is clearly less than 0.01, and therefore you are going to reject H0. We have a completely different situation here. I can't emphasize this enough. So, of course, I recommend you use technology, but no matter what you do, if you're justifying your answer, it will be always right. Now, we're going to do the same question, and we want to make a 98% confidence interval. The reason 98%, because alpha of 0.01 for a one-tail test, whether it's left-tail test or right-tail test makes no difference. The whole area is on one side. It is equivalent to a 98% confidence interval. So when we go through the process, what I want to show you is interesting. I want you to take a look and pay attention to what's going on. Remember, the formula for t was x1 bar minus x2 bar over the square root of s1 squared over n1 plus s2 squared over. Take a look at the denominator. When we want to calculate the confidence interval, we have x1 bar minus x2 bar plus minus e, where e is t alpha over 2 and the square root of the same thing. Why am I showing you that? Because I want to show you that actually this calculation will be a piece of cake. The numerator that you have already calculated here, it's this one. So in other words, use this in this step, keep all your calculations. So x1 bar minus x2 bar is the numerator. And then plus minus e, you can calculate the e by multiplying this, which is 2.426, by the square root of this. You don't have to recalculate it. It's been already done here, because look at this formula, look at this one, look at this one. So plug in. The point being, You can calculate this very fast. So T 2.426. What is this whole mess? You already have it in the denominator of your test statistic. And now you put it here. -3 goes here, plus minus this number is here. Take a look. That's where it comes from. And so therefore, mu sub 1 minus mu sub 2 is between these two values, which is between negative 6.04504 and positive 0.04504. And because the confidence interval limits contain zero, notice we go from negative to positive. Therefore, zero is in between. Because the confidence interval limits contain zero, there is not a significant difference between the two means. Fail to reject the null hypothesis. Let's look at technology and calculate the two sample t interval. Again, when you put it in, it asks you for all the information that you already have. You plug it in. When you get to sea level, you put 98% or 0.98. Pooled, no, you do the calculation. And this is what you get. And again, note the difference that you have here, simply because with the calculator, we have a degrees of freedom as we did in the previous page, 77.11. So this will give you the same decision as technology for the previous page, which says, because the confidence interval limits do not contain zero. Why? We go from negative to negative. Because the confidence interval limits do not contain zero, there is a significant difference between the two means. Therefore, reject the null hypothesis. Now, we're going to look at the same question, but now we're going to go with equal variances, which means we're going to pull the data, and that's why we have this one here. So we have the same question, the same information, the difference is this, and therefore the test statistic has a different formula. Instead of S1 and S2, we have S sub P, which is called the pooled variance. And how do you calculate the pooled variance? Again, it's really the weighted average of the two S's, if you will, the standard deviation for the first one, the standard deviation for the second one when you score it, or the variance. So you calculate this with the first step being the same as before, identical. This is being repeated. And we need to calculate this to get to the test statistic. Let's plug in. I can't emphasize the importance of writing this information, so it makes life easier when you want to calculate things. Plug in, it gives you S sub P squared. So when you go to this formula, this doesn't have to get squared, it is squared of it. So plug it in, calculate the test statistic. By the way, this always comes from H1, and it's at least for us will be always 0. So we have negative 2.4316, a critical value. Now this, the way the critical value help us here is with the degrees of freedom is n1 minus 1 plus n2 minus 1. In other words, add them up. 40 and 50, 90 minus 2, because this is 50 minus 1, this is 40 minus 1, and it gives us 88 with the alpha of a 0.01. And when we look this up using the table, we get this number, because that's the closest number to 88. Now, let us use the graph to see how it looks like. The critical value is negative 2.368. Test statistic is negative 2.4316, which puts us way into the rejection region. So now we're going to reject H0. When you reject H0, loosely put you accept H1, the claim becomes true. And we write reject H0 because the value of test statistic is inside the rejection region. The claim is true. There is sufficient evidence to support the claim that company A's yogurt cups contain on average less calories than that of its competitor, company B. By the way, if we were to go with the p-value as far as the drawing is concerned, the p-value would be, this is where the test statistic is, and so this area, which is clearly less than the choice of alpha. So let's move on. And we want to calculate the p-value and make a decision. And as I said, area to the left of the test statistic, and the degrees of freedom is 90. If you want to go with the table, you don't get a precise answer, but you see the p-value is between these two, and we have the same decision. However, most likely you go with a technology, and if you want to use the technology, this is the one that you want to be careful. You're going to use two-sample t-test, and you're going to use the pooled because we are using equal variances. When we do that, and they ask us about the information we put in, and this is important to be careful. It results in the following. It calculates everything for us. See, degrees of freedom is the same thing that we mentioned, 40 plus 50, and subtract to 1 from here, 1 from here. That's why it's 88. And take a look at the p-value. The p-value is 0.0085, which is clearly less than alpha of 0.01, and technology gives us the same decision. So that's pretty simple because the degrees of freedom from the way we calculate and the way the calculator does is the same. Now, what if we want to get a 98% confidence interval? Again, it's x1 bar plus minus x2 bar plus minus e. And I want to remind you of this formula, which we have done, versus E, which is this formula. This one is identical to this. Recall when we did the test statistic. So the numerator is this, and the denominator is this. You don't have to calculate. I mentioned this because it will speed up your calculation a lot, especially if everything is done by hand. Notice this is identical to this. Therefore, all you have to do, plug in t here, which is 2.368, and this comes from here, right? Their product is 2.9216. So now here, this one from the numerator here is -3, and plus minus this number. When we do that, we get -5.9216, less than mu1 minus mu2, less than -0.0784. And because the confidence interval limits do not contain 0, notice, we go from negative to negative. There is a significant difference between the two means, reject the null hypothesis. We get to the same decision. If we were to do this by technology, we will go with two-sample t interval, and we plug in everything that they ask us. In the case of a C level, we put 0.98, 98%. Is it pooled? Yes, equal variances, that's the meaning of it. And as you can see, this is the same, very close to that. It's not identical simply because they use more decimals and their t is slightly different, but it's very close, negative 5.9 to negative 0.08. This is negative 0.08 as well. If you go with a couple of decimals, they are identical. All right, we want to test a claim that weights of male college students have a larger variance than female college students, and we want to use a significance level of a 0.05. And here's the information given to us. We don't have to do much. Everything is given symbolically with alpha of a 0.05. So either they tell us it's normal population or we have to assume that in order to continue. Alpha is 0.05, and the information, as I said, it's here. And basically, we really don't need the X bar. So the first step is to write H0 and H1. So I want you to see I have three different ways of writing them, and I want you to follow that. You can say sigma 1 squared equals to sigma 2 squared. And then sigma 1 squared is larger than sigma 2 squared. You may say sigma 1 squared to sigma 2 squared is 1. You look at the ratio, where sigma 1 squared over sigma 2 squared is larger than 1. Or you may say sigma 1 equals to sigma 2, sigma 1 is larger than sigma 2. Please understand they are equivalent, but don't mix them up. If you're using sigma 1 squared equals sigma 2 squared, keep it in the same manner. This is the claim. This is right tail test because it says larger variance. And we use what's called F distribution. So the very first thing we have to calculate is test statistic. F equals S1 squared over S2 squared. So plug in. The next step is the critical value. Critical value comes from the choice of alpha is 0.05, and degrees of freedom of the numerator is, for the numerator is 31 minus 1. For the denominator is 29 minus 1. Or 28. So you go to the F distribution and you have to go with alpha because equals 0.05. If you're using technology, it's easier. If you're not using technology, pay attention that alpha must read 0.05. So when you go to the table, there are different tables. We are looking for this table, and this is the degrees of freedom of the numerator. On the left column, degrees of freedom of denominator, we are looking for 28, so we find 28. And at top here, we are looking for 30, we find 30. When we put them together, here's the answer, which is 1.8687. This is reading the F distribution table with alpha of 0.05. To make a decision, we go with the graph. And in this case, alpha is 0.05, F is 1.8687. That is the critical value. We throw in the test statistic to see where it lands. As you can see, it lands here. By the way, F distribution is all positive, so it's way into the non-rejection region. Therefore, fail to reject the null hypothesis. So you're not rejecting H0. What are you rejecting? H1. So the claim is false, and you write fail to reject the null hypothesis because the value of test statistic falls in the non-rejection region. The claim is false. There is not sufficient evidence to support the claim that weights of male college students have a larger variance than female college students. And that takes care of the business. If we were to do a technology, we go with two sample F test and we put the information that they ask us. That's why we have it here. And by the way, F distribution is very limited on a normal basis, especially without the technology. They always make it right tail test. You always choose the two groups such that the one with the larger S is the first group. And that's why if you follow that, it can become a right tail test. So the one with the larger S is the first group. S1 squared over S2 squared because of this. And so when you go with that, you see F is 1.2544. That's what we calculated. Look at the p-value. The p-value is 0.275, let's say, which is clearly larger than alpha of 0.05, and failed to reject the null hypothesis, the same decision. So the p-value from the technology. So that was F distribution. Could you read this question, please?
Sure. Directional directional asymmetry, dA, is a phenomenon whereby in a population, one side of each organism is consistently larger than the other, i.e., left larger than right. An evolutionary biologist studying dA measures the length of the left and of right wings of a sample of Drosophila, a type of flies whose members are often called small fruit flies, collected from nature, and she gets these data. A, the researcher decides to perform a two-sample t-test to determine whether the mean of the wing differs between the left and the right sides of these flies. What type of t-test will she do? A is equal to 0.05. B, find the 95% confidence interval for the difference between the means.
Perfect. So we are going to use a paired t-test because we are looking at the same species, the length of the left and the right wing. So paired t-test. Then to do that, we can look at the difference between the two and calculate them. For example, for the first one, we can say 1.34 minus 1.26, and that gives us 0.08. For the second one, 1 minus 1.28 is negative 0.28, and we continue all the way to the end. And if you look at the difference and you call it D, then we have these formulas. D bar is summation of D divided by N. This is how you find the mean. Standard deviation, just the same as if you recall when we did the X bar with the X, we would use summation of X minus X bar quantity squared over N minus 1. Now it's D minus D bar. By the way, in some texts they use lowercase d, in some texts they use uppercase d. It doesn't make any difference. And so we can calculate it by hand, or with technology we plug in, we put all of this into technology, and I'm reminding you how to set this up. You can put them in L1 and L2. Look at L1 minus L2, store it in L3, and do the stats on that, and it will result in D bar. And on purpose, I used capital D here versus lowercase d to tell you depends on the text. They both mean the same thing. And S sub D, that means this last column, the mean is negative 0.0906, and the standard deviation is 0.2283. And of course, we have 17 pieces. N is 17. And now we are ready to do the test of hypothesis. So this is paired t-test. This is the information from the previous page. And this is the formula for the test statistic. By the way, again, when we do the test of hypothesis for one population, the t-test, that's exactly the same as this one. Instead of D bar, we use X bar. So in essence, you use the same test on the difference. So step one, H0, mu sub D 0, H1 mu sub D is not equal to 0 because in part A, the researcher desires to perform a two-sample t-test to determine whether the mean wing differs between the left and right. So that means, is it less than, is it greater than? Either one is fine. That's why we don't go with less than or greater than. Not equal to, it's a two-tailed test, and that is the claim. Let's calculate the test statistic by using this formula. And again, lowercase versus uppercase, it depends on the text. So we've have all of those, d bar minus mu of d over s of d divided by square root of n, plug in. And by the way, mu sub d comes from h0 and it's 0. You do the math, you end up with negative 1.636. Critical value alpha is 0.05. Normally in biology, in many sciences, they use alpha to be 0.05. In some cases, they may not even give you an alpha, but normally it's 0.05. And degrees of freedom, as always, n minus 1, 17 minus 1 is 16. Alpha is 0.05. Looking up the table, we get plus minus 2.120. And to make a decision, we go with the graph. So this is negative 2.120. This is positive 2.120. And the test statistic that is calculated, negative 1.636, is somewhere in between, and it's in a non-rejection region. It's in a non-rejection region. So what happens? You do not reject H0. So if you're not rejecting H0, what are you rejecting? H1, which means you're rejecting the claim becomes false, and you write as follows. Do not reject H0. The claim is false. There is not sufficient evidence to support the claim that the mean wing differs between the left and right sides of these flies. So she cannot conclude that this population processes dA because the mean length of the wings on the left and right sides do not differ significantly. And I'm going to put up the methodology that you can use with technology. I'm not going to do that, but you can try it. And we're going to continue to get a 95% confidence interval. Remember, alpha was 0.05. And because it was a two-tailed test, 1 minus that means 95% confidence interval is equivalent to that. And all of this information is from the previous page. So I don't want to go through the same calculation. So everything that you have here is from what we have already done. And so we are going to look at E, which is T alpha over 2S sub D over square root of N. We're going to calculate this because if you recall, in the case of a X bar, we say X bar plus minus E. And in the case of a D bar, we're going to say D bar plus minus E. So let us calculate the E. (2.120) times S is 0.2283 divided by square root of N, which is 17. And now D bar is this number plus minus this number. Now, when we do the math, mu sub D is between negative 0.208 and positive 0.268. Since 0 is contained in the interval, the decision is to reject the null hypothesis, is to not reject the null hypothesis, because 0 is contained in the interval. We failed to reject H0. Do not reject H0. All right, let's look at the technology again. If we want to use it, we use match pair T interval, and Let's look at the last question. Could you be kind enough to read this question for us, please?
Sure thing. An ecologist is concerned with whether population entering a part of a preserve area is compromising the health and growth of an endangered species of snake. To determine this, he decides to measure the length of a set of mature adults from the polluted area and the unpolluted area. The researcher decides to perform a two-sample t-test to determine whether the mean length of these two snakes differs between these two areas. Alpha equals 0.05.
Excellent. So we have unpolluted area, we have polluted area, we've collected the sample, so we need to run it and calculate the sample mean, sample standard deviation, and so on and so forth. So we can do it by hand. We can put it into a calculator. And when we do that, standard deviation for the first group, if you will, the unpolluted area is this number with a bunch of decimals, 2.658, and it continues. For the next group is 2.620, and it continues. The mean, 27.266, and the mean is 24.647 for the next one. We have 15 pieces, is the sample size 15 pieces for the unpolluted area and 17 from the polluted area. So that's the first part we do because we have to have all of those to start the test of hypothesis. H is 0, mu1 equals mu2. H1, mu1 is not equal to mu2 because we are determining whether the mean length of these snakes differ. We then say less than, greater than. And since we are looking to see whether this is the case, we're going to call this the claim and a two-tailed test. So we calculate the test statistic using the same good old formula, x1 bar minus x2 bar over the square root of s1 squared over n1 plus s2 squared over n2. And when we are done with that, we end up with 2.8022. Now, I want to show you again with technology and without that. So critical value is from the choice of alpha, 0.05. And degrees of freedom is the smaller of the two, 15 minus 1 and 17 minus 1 result in 14 because of the limitation that we have with the calculation if you want to do it by hand. And from the table, t becomes plus minus 2.145. And let's do the drawing. This is plus minus 2.145. And the test statistic 2.8022 is even larger than 2.145. So it's way into the rejection region. So this location tells you reject H0. When you reject H0, that means you accept H1 loosely put. Therefore, the claim becomes true, and you write as follows. Reject H0. The claim is true. There is enough evidence to support the claim that the mean length of these snakes differs in these areas. It is larger in the unpolluted area since test statistic is positive. There are a couple of ways to see that. We were looking at the difference between the two. This is positive. Also, if you look at the mean, you see the mean on the average is larger for the unpolluted area. So after you make this decision that you reject H0, you can see that it's larger in the unpolluted area. And that shows how effective this thing is. Now, if we go with the calculator as before uses this complicated formula. I'm going to put up the formula that I mentioned, and it will calculate it using that formula, becomes 29.3930, so on and so forth. And they actually take it down to 29 if you were to look up the t, and the t is 2.800. This is the test statistic, everybody. as we calculated. And so what happens here, you want to pay attention to this one, which is the p-value. The p-value, so we always round it down, if you will. So CV alpha is 0.05, degrees of freedom is 29, round down always. T is plus minus 2.045. And the p-value, according to this, is 0.0089, or you can say 0.009, which is clearly less than alpha of 0.05. And therefore, we happen to get to the same answer. The reason being, because the difference between this degrees of freedom and this degrees of freedom is not as big as the last one with it. Therefore, they give us the same result.